Here's our third conversation for Chapter 11 about the atomic nature of matter. And this one will include isotopes, compounds and mixtures, and molecules. You do have a lot of vocabulary for this chapter. Make sure that you take a look at that and keep them straight. Hopefully a lot of this is a review from your chemistry classes. Quick look back at the periodic table that we've already talked about, and among all the other interesting things that you can pull out of the periodic table is the electronegativity, the relative electronegativity of the different elements. Electronegativity is the ability of an atom to pull electrons toward itself. And you can see from the scale that some are better than others. Some are true electron seekers. Generally, your electronegativity increases as the number of protons in the atom increases, or will also be related to the electron shells that have been filled. This is important when we look at the bonding and when we look at our study of electricity later on. It's actually, when you look at it on an atomic level, it is similar to our study with gravitational forces and tides on the Earth. As in our case, in that case, the forces were, when we looked at the tides, the force was the gravitational draw from the moon. In this case, we have an electrical draw to atoms with more protons in their nucleus, but it's a similar sort of phenomena. When we talk about an ion, and again, keep your vocabulary straight, an ion is going to be a charged atom, either that has drawn electrons toward itself or has given away electrons to somebody else. Contrast with that with an isotope. And for an isotope, the thing that has changed is the number of neutrons. So the charge is unchanged. The mass of it, though, is changed from the original. So an ion is a change with the electrons. An isotope is a change of the neutrons. Ions will behave differently than the original material, whereas an isotope does not. Remember your atomic structures, that our protons balance the electrons, and neutrons are going to be something different, whereas our isotopes have a change in the neutron. And when you see those, it will be indicated with a number, the mass with a number indicating its isotope. So here's your question, the atomic number of the element, what does that indicate? It indicates both the protons and the electrons. And if they don't match, then that makes that atom an ion. Here's another question for you. And the answer would be 56 neutrons. Don't confuse the idea of a neutron with a nucleon. Two different things. All right, we've talked about ions, we've talked about isotopes. Distinguish that from a compound and a mixture. A compound is when a new material has been created and chemically and is not going to be separated by mechanical means. A mixture can be separated mechanically. A mixture is not any new molecular structure. It's just a combination of different materials, whereas a compound is a new molecular structure. A good example of that is that sodium chloride, salt, is a compound, but salt in water is a mixture because we can still, when the water evaporates, it's still salt. Remember that a molecule is when atoms are bonded together. They're bonded together because they have traded electrons in some way. Uh, they don't really look like these cartoons, but this is a general way to describe them. And we'll call it a chemical reaction when the atoms rearrange by giving electrons back and forth. Remember that the conservation laws continue to apply. So as the molecules rearrange themselves, they either need energy from an outside source or release energy. But there are, and hopefully you remember from chemistry things like reactions forming heat or maybe more violent creation of energy.